we're going to get some area of some composite shapes. And there's always a couple of different ways that you can go about it. Like even for A, you could cut it across here and get this shape and that shape, or you could cut it down here and get the two shapes. It's really however you'd want to do it given the values that you've got. You might have to do some sort of deduction. I'll just leave it like this for now. So this first shape, which I'm going to call shape A, I know it's 5 across, and that means it's going to be 5 down here. And how tall it is going to be, see that line there? That means that's 5. This is also 5. It's 8 up here. 5 plus 8 is 13. So it's just going to be 5 times 13, which I believe that is 65. Okay, this remaining part is 6 across. It's 5 up, as we can tell by the dash. 6 times 5 is 30. If this piece is 30, that one is 65. We add them together, 95 centimeters squared. Now if we head over towards B. B, I'm going to try to do the whole area minus this little white section in the middle. So the whole area is going to be 100 millimeters across and 80 millimeters down. 80 times 100 will be, that'll be 8,000. So that's the total. But now I want to subtract this little section in here. So I know that it's 60 up and it's 40 across. 60 times 40 is going to be 2,400. So that's the whole big area, the rectangle all the way around the outside. Take away this little rectangle in here. I'm going to end up being left with, I believe that will be 5,600 millimeters squared. Obviously be putting things in your calculator to make sure that you're getting it right. Over here for C, we've got 4 and then we've got 5 all the way across. Same on both sides. So this shape here, which I'll call shape A, is going to be 4 times 5, 20 meters squared. And then this one here, I'll use half pi r squared, because I use pi r squared for a circle, but I'm going to use half pi r squared for a semicircle. So it's going to be half times, well, the radius I'll need, by the way, as well, sorry, from one side to the other is going to be 2, because it's 4 from top to bottom, but that's the diameter. I need the radius, so it's 2. So it's going to be half times pi times radius of 2 squared, and that gives me 6.28. Add my 6.28 plus my 20, and I get 26.28 meters squared. This one over here, again, you can cut it any way you want. This time around, I'm going to go horizontal line instead of vertical like over here. So I know that it's 2 kilometers. It's 2.3 across, and it's another 1 across, so it's 3.3 across. Okay, and then it's going to be going up here with the dash. It's going to be 2. 2 refers to that dash, so it's going to be 3.3 times 2, which will be 6.6 kilometers squared for shape A. And then shape B is just going to be 2 times 1, which equals 2. For shape B, you add them together and you'll get, with my little plus sign, you'll get 8.6 kilometers squared. Okay, now for E, we're going to do the same as before. We're going to try and solve for the whole lot and then just get rid of our little gremlin spots. 1, 2, 3. We've got 3 of them that we're going to get rid of. So when I figure out the area for one of them, I'm going to multiply that by 3 as the thing that I'm going to get rid of. First up, 49 times 30. I'll just chuck that in my calculator. 49 times 30 will get me 1470. That is for the entire area. 49 across, 30 up. Okay, that's my 1470. Now I'm going to cut out 3 of these little areas. Now it doesn't actually tell us what the areas are, but it does tell us that there's 1, 2, 3, 4, 5, 6, 7 across, and it's 49 meters in total, and it says that they're all the same. So each of them is going to be 1/7 of 49, and 49 divided by 7 is 7. So they're actually going to be 7 by 7 meter squares. And I've got 3 of them. 7 times 7 is 49. 49 times 3, I believe, will be 147. And then that means my 3 areas were 147 each. And then I've just got to do the subtraction. Take 147 from 1470, and you end up getting 1323 meters squared. Now when we come to F, we're doing a combination of things. First things first, you have got a square in the middle, 6 times 6, so that one's going to be 36. Then you've got your circles. Now remember, pi r squared. It's what we use to solve for circles. And we've got 2 circles, yeah? Because we've got this and this, which make a circle, and this one, which makes another circle. So we've got 2 circles worth. So we'll figure out the answer for one of them, and then we'll just multiply it by 2, okay? So pi r squared, the r will be half of 6, because 6 is a diameter from one way across all the way to the other. So it's going to be 3 pi times 3 squared. So put that into your calculator. Pi times 3 squared is 28.27. So that is going to be the area of one of my circles. So I'm going to multiply that by 2 on my calculator, and it gives me 56.54. I'll add my 36 of my square in the middle, and I'll get 92.548, which I'm going to round up to 92.55 centimeters squared. That's the answer for F. Now, last one, G. Again, you've got a couple of different shapes going on. First up, I'm going to do shape A over here, my semicircle. So you're going to do half pi r squared, because it's half a circle. And my radius is going to be 1, because that's the diameter, which is 2 from one side to the other. So it's just going to be half times pi times 1 squared, which is, of course, is just going to be half times pi, and you're going to get 1.57 meters. That's for that shape, squared. Then you're going to have to do half base times height for the other side, for the triangle. So half base times height is just going to be, or another way of looking at it actually, because these sides are even and because of the right angle, you can actually just imagine that you have grabbed this piece here and you end up putting it here. So you are actually going to have a rectangle. That's going to be 1.7 times 1. So that's just going to be 1.7. And if you add those two together, you end up getting 3.27 meters squared.